Hello students, in this week's video, we'll be covering two subtopics. The first one is rates of change, and the second one is connected rate of change. So do get some papers and a pen and practice along with me. The questions for rates of change will be from exercise 13.2. Let's look at question 1. So you're given the height in kilometers of a rocket above the ground and is given by a function h bracket t equals to t bracket 10 minus t over 4. And in this question, t is the time in seconds from its launch. And you asked to find the rate of change of h with respect to t, okay, when t is 2 seconds and when t is 6 seconds. All right. So first of all, let's understand what do we mean by the rate of change of h. How do we convert that rate of change of h into mathematical symbol? Yes, rate of change of h refers to dh over dt. That means we are finding the rate of change of h with respect to time, meaning we need to differentiate h bracket t. All right, so let's do it. So step number 1 is to simplify, expand the bracket. So you end up getting 10t minus t squared over 4. And to make our differentiation even easier, let's separate it into such that we make it into 1/4 times 10t minus 4 minus t squared. Why do you want to do that? It's because we are just interested in differentiating 10t and t squared. Right. Some of you may want to put it this way. Separate into two fractions. And that's fine. All right, you can do it this way also. But please don't use product rule, okay? It is not worth all the efforts to use product rule here. Okay, this is just simple differentiation using the chain rule. All right. No, sorry, not even chain rule, just the power rule. All right, so we're finding the h over dt. So there are two ways of writing it. You can write it as d bracket or you can simply just write it as h prime bracket t. Okay, so differentiate 10t, you will get 10. And differentiate t squared, you get 2t, and make sure the negative is there. All right, so that is our rate of change. Your h prime t is our rate of change. So what we need to do is at t equals to 2, right, we substitute it into our rate of change, h prime t, and you get 1.5 kilometer per second. That means at t equals to 2, the height, okay, the height of the rocket, it's at 1.5 kilometer per second. And when t is equals to 6, the rate of change of your height respect to t, it's negative 0.5 kilometer per second. Right, so do remember to put in the units because the height, the dimensions for height will be kilometer and you're finding rate of change, so it should be kilometer per second. Right, so what does this negative tells you? So this negative tells you that the rate of change of the height respect to t is decreasing. Okay, it's decreasing. So it increases first and then it decreases. All right, let's look at question 2. So for question 2, we're given an elastic string. Right, it's a string that you can actually stretch, make it longer or make it shorter, and it's given by a certain a cubic equation. right? The length, L represent the length, is equals to t cubed over 3 minus 5t plus 8. So what we're interested to find is at what time the values of t represent the time in seconds. At what time is the length increasing at the rate of 4 millimeter per second? And for part 2, at what time when the length is decreasing at the rate of 5 millimeter per second? All right, so let's look at part I first. So to find the rate of change, if you're talking about the length is increasing or decreasing, that means we're finding the rate of change of the length. So the rate of change of the length refers to your dl over dt. All right, so that means we need to differentiate L with respect to t. So you see that I rewrite t3 over t cubed over 3 as 1/3. Right, so that I can apply the power rule easier. All right, so let's find the L over dt using the power rule. So you differentiate t cubed, you get 3t squared. Differentiate 5t, you get 5. Differentiate 8, you get 0. All right, so that is our rate of change. So for part I, we're going to substitute this value equals to 4 because you're given here that the length is increasing. So this is our dl over dt. And it is a positive value because it's increasing. It's increasing because therefore it's a positive value. So we're going to equate 1/3. Okay, we're going to simplify that first because 1/3 times 3 will just give you 1. So that ends up t squared minus 5. And we're going to equate that to 4. And from there, you get a quadratic equation. T squared equals to 9. So t can be positive 3 or negative 3. However, we're talking about time, and we have to reject the negative value. So therefore, t is equals to 3. Right, so part 2 is a bit tricky. Why a bit tricky? Because you're told that the length is decreasing. So therefore, remember to put your negative there. It's negative 5 millimeter per second because it's decreasing. So just differentiate between part I and part 2. Okay, part I is a positive value because it's increasing. Part 2 is a negative value because it is decreasing. Right, so t squared minus 5 equals to negative 5. You end up getting t squared equals to 0, so t is equals to 0. Okay, so that's how we do it. Right, let's look at question 4. So question 4, you're given a balloon. Right, so the radius of the balloon is given by a certain function where it is r equals to 3 plus 2 over t plus 1. And for part I, we are asked to find what was its initial radius. So we need to understand what's the meaning of this word, these two words, initial radius. So initial means the beginning, means the first time when you see the balloon, right? It's when nothing has happened yet. Right, so that is when t is equal to 0. Right, when nothing has happened yet. So t is equal to 0. So we're going to substitute t equals to 0 into the functions given for your radius. Right, and you will have the initial one is 5 centimeter. So when the first time you see the balloon, the radius is 5 centimeter. That's what it means. And maybe later on the balloon will be like increasing, get bigger and bigger and bigger, or get smaller and smaller and smaller. Okay, that is when we look at part 2. Right. So you see what I've done here is I actually convert it into, for this one, I convert it into a negative index. Right, so for some of you who have forgotten how to do it, I'm going to show you step by step again. 2 over 1 is just 2, and then this one will give you bracket t plus 1 to the power negative 1. So that's explained how I end up here. Okay, and why do I want to do that? Is because of part 2, because I need to find the rate of change of radius with respect to t. Basically, I need to find the r over dt. So basically, I need to differentiate 2 over t plus 1. Okay, Right, so for part 2, we're asked to find the rate of change of R, rate of change of R. So that refers to your dr, because rate of change of R, dr over respect to t means dt. Okay, so rate of change of R with respect to t means dr over dt, meaning you differentiate your R respect to t. Okay, so we're going to do that. So you differentiate 3, you get 0. So this one we have to use our chain rule. Okay, you bring your negative 1 to the front, become negative 2, leave t plus 1 alone, negative 1 minus 1 to get negative 2. Where does this 1 come from? Is you need to differentiate the term inside the bracket. So you differentiate t, you get 1. And of course, differentiate 1, you get 0 lah. So that's why it times 1. Okay, so that is our rate of change of radius with respect to t. Right, so what happened when t is 3? So we're going to substitute t equals to 3 into your dr over dt. And you get negative 1 over 8 centimeter per second. Right, so the question says suggest what may be happening to the balloon. So if you see this negative, what do you think happened to the balloon? Is it getting bigger or getting smaller? Yes, of course, the negative tells you that it's deflating, it's getting smaller. Right, so this is how you explain it. Okay, professional way of explaining it. Since the rate of change of R respect to t is a negative value, negative 1 over 8 is a negative value, the balloon is deflating at this instant. That means at t equals to 3 seconds, the balloon is getting smaller. This is what it means. Right, so let's look at question 6. Question 6 is a rather challenging question. If you see, it's colored red. Right, so what happened is that this is a question involving some physics concepts, but you don't really need to know in much detail. All we are saying is that there are two resistors combined together give you a combined resistance which is given by this particular formula. Right, the only thing you need to take note is R2 is a constant. Right, so what is a constant? This one is a constant. What's a constant? So basically constant is just a value that does not change. So it could be 2, could be 3, could be 6, could be 9, whatever. That means it does not change at all. Okay, constant is it does not change. The value does not change. So when you differentiate a constant, what do you get? Yes, you get 0. That's the point. Okay, so what we are differentiating is we need to find the rate of change of the combined resistance. So what does this mean? This means we need to find your dr. With respect to the changes in R1 means what? Means we need to find the R1. So if you combine them, what is it that we are finding? We're actually finding dr over dr1. Okay, combine both of them, we are finding dr over dr1. So I need to make R the subject here. Can you see what you're given here? It's 1 over R as a subject, not R. So we need to apply some algebraic skill to combine them into a single fractions. Okay, so in this case here, I would have to make my common denominator to be R1, R2. So this time R2, this time R1. So I would end up having 1 over R equals, okay, right. So then now I can do a flip because I have a single fraction. Okay, please remember, you can only do that when you have a single fraction. You see, I can just circle only one circle on the left, one circle on the right. Not like this. If you have something like that, right? Then you cannot flip. Okay, cannot flip. Right, but if you have only one circle on the left and one huge circle on the right, you can just do a flip. You'll get R over 1, which is R, equals to R1, R2 over R2 plus R1. Okay, so to make life easier for us, because there's so many R, oh my god, R1, R2, R, and your R2 is a constant, I'm just going to replace your R2 with a letter A. You can replace it with any other letters you want. Okay, you can replace it with B, C, D, whatever, or X. Or don't replace with X, you're confused. Just replace with a letter, and just remember that your letter is a constant. So here we're going to use product rule. So you replace R2 with A. All right. So we need to differentiate the R respect to R1. So what you get, you only get R1. Just like, okay, just like if you think of R1 as X, you need to differentiate U respect to X, right? Here you get XA. So you differentiate X, you get 1. You get 1, right? Differentiate X, you get 1, right? Differentiate AX, so you get A only. Okay, so A is a constant, differentiate constant, you get 0. You differentiate R1, you get 1. Okay, then you apply your quotient rule. Okay, your quotient rule, sub in your V, sub in your du over the R1, blah, 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 you get this thing, this whole chunk of thing here. That is your quotient rule. And if you look at it very carefully, you can see that there's a common factor, you can extract it out, and that is your A. A is a common factor. So you pull out your A, so you're left only this, and left only negative R1 here. Now, but bear in mind, okay, and then your R1 minus R1 will be gone, so you only left A times A. So remember your A is a replaced value for R2. So you need to put back your A to be R2. So you end up having A times A, which is R2 times R2 gives you R2 bracket square. And also A, replace it back with the R2. Okay. So this is one way of doing it if you're very confused with so many R. And if you're not confused, if your mind is very clear, okay, enough sleep, then you can just leave R2 as R2. Just remember R2 is a constant. Okay, so that's all for this video. Hope you enjoyed it.